Hey friends, so today we're going to tackle lesson 5, which is area between the curves. Now, if you followed through with me all the way through lesson 4, I don't think lesson 5 is going to be a huge leap for you, because really what happens is we end up having to do lesson 4 twice, and you'll see what I mean in just a minute. Okay, but just to recap with lesson 4, we found out that we could figure out the area underneath a curve and above the x-axis, or really between the x-axis and the curve, right? It didn't actually matter which one of those was on top. But we could get the area between the x-axis and the curve by essentially evaluating the integral of f of x from point A to point B. Okay, and so we developed that formula that was big f of x at, big f of b minus big f of a, and that would give us the area in between a and b. Okay, so what we want to do today is we want to look at trying to get the area in between two curves instead of the area in between a curve and an axis. Okay, okay, so sometimes we will be asked to find the area between two curves, f1 of x and f2 of x, or sometimes they're just called f and g. Okay, so there's two kind of scenarios we want to look at. The first is when one curve is always on top. So take a look at the picture here. And I'm just going to hide myself for a second because I'm probably in the way. Could we determine the individual areas under the curve and use those somehow? So I'm just going to grab a highlighter here for a second, and I want to show you. This is f of 1. This blue line here is f of 1, right? So if I shaded this region in here, this would be the area of f of 1 from point A to point B. And I would take the integral of f of 1 and evaluate it from point A to point B, right? Okay, but now take a look if I switch colors and look at f of 2, this guy here would represent the area of f of 2, right? And that's actually the piece that I don't want in my original area. And so what I could do, I could find that area just like I found the area of f of 1, right? That's why I said earlier that it was kind of like two lesson 4s put together. I'm going to come back now. I missed seeing you. Okay, there I am. So essentially what I do is I take the area of f of 1, and then from it, I subtract the area of f of 2. And then what's left over is the actual space that I wanted in the first place. Okay, so find the area under f of 1 from A to B. And we've done that. That's exactly what we did in lesson 4. Then find the area under f of 2 from A to B. We've done that. That's exactly what we did in lesson 4. Okay, but then I need to take those two areas and subtract them, and that will get me the area in between the two curves. Okay, so really no more difficult than what we did last time. It's just a little more work because it's like two questions in one. Okay, so we say that the area of x would be the integral of f of 1 minus f of 2. Okay, the integral of f of 1 minus f of 2, where f of 1 is the top function and f of 2 is the bottom function. Okay, so it's top minus the bottom. Whoever's on top, subtract whoever's on bottom. All right, then we can take a look at case 2, where one curve is not always on top. How would we adjust our formula? Now, again, I'm just going to take my big old head out of the way here for a second. Okay, and really, I think, again, I don't think this is a huge leap for you. We're just going to have to count this as two different sets that we add together, right? If I separate this into from here to here, I'm going to have to go f of x minus g of x because f of x is on top, right? And then if I separate from, I just want to switch colors here for you, here to here, from there to there, I'm going to have to go g of x minus f of x because g of x is on top. And then I just add those two things together. Okay, easy peasy lemon squeezy. All is going to be well on this guy. Okay, so the total area will be area 1 plus area 2, where area 1 is the integral of f of x minus g of x, and area 2 is the integral of g of x minus f of x. So it's always the curve on top minus the curve on the bottom, okay? Okay, so determine the area bounded by these two equations, y equals x squared and y equals the root of x. Well, the first thing I'm going to have to do is I'm going to have to look for various intersection points between these two, because where I intersect is where I'm going to switch between who's on top and who's on the bottom. Okay, so in order for me to solve the intersection of these 2 points, which is essentially where I want to get a and b as well, I just set them equal to each other because they're both equal to y, right? So I go x squared equals the root of x, which is x to the 4 equals x, okay, which is x to the 4 minus x equals 0. Factor out an x. And I'm left with x times x cubed minus 1. Okay, so I know this guy here tells me I got a 0. And this guy here tells me I get a 1. So my intersections are at 0 and 1. Okay, now I have a rough idea, or I should, of what x squared looks like, right? And I have a rough idea of what root x should look like. And I know that my intersection points are at 0 and 1. Okay, so that is the spot, which I know I'm really kind of teeny tiny in this video, but this spot right here is the area in between those two curves. So I want to calculate, there's always only one on top for this guy, and it happens to be the root of x is the guy on top. So I'm gonna go the integral of root of x from 0 to 1 minus the integral of x squared from 0 to 1, okay? So here is a picture. Just a bigger picture, and I'll hide myself for a second just so that you can see it, but that's essentially what I drew in teeny tiny form on the whiteboard behind me. Okay, and so I'm going to go, which function is on top? I already answered that, that was root of x. Okay, and so I go the integral from 0 to 1 of the root of x minus x squared. Okay, so I just have to take the integral of this. Root of x is x to the 1/2. So if I want to take the integral of that, the 1/2 goes up to 3 over 2. I divide 1 by 3 over 2, so that'll be 2 over 3, x to the 3 over 2. This guy here, my 2 goes up to a 3, right? These are all things we've already done when we discussed how to take an antiderivative, right? So the 2 goes up to a 3, so that'll be 1/3 x cubed. Okay, so I'm going to evaluate this now from 0 to 1. So that means I plug in 1, and then figure that out, and then I plug in 0, figure that out, and subtract them. Okay, so I plug in 1, figure that out, plug in 0, figure that out, and subtract them. Total answer, the area would be 1/3 units squared. 1/3 units squared. Okay. All right. See, that wasn't bad. Let's do the next one. Determine the area bounded by y equals 2x squared plus 5 and y equals x plus 1. This time, I'm just going to hide myself so you can see those equations for a second. This time I'm asked to do it from 1 to 4. Okay, from 1 to 4. So the first thing I do is give myself a little picture. Okay, I'll again hide myself for a second. I've got y equals 2x squared plus 5. And y equals x plus 1 is my red guy. So I can see that 2x squared plus 5 is always on top. Okay, 2x squared plus 5 is always on top. All right, so I'm gonna end up going the integral of 2x squared plus 5 minus x plus 1. And I'm gonna do that from 1 to 4. Okay, but I can now clean this up and look at this as one equation before I go and take the integral of it now. So that's 2x squared plus 5 minus x and minus 1. So that's 2x squared minus x plus 4. Okay, I now want to take the integration of that. So x squared goes to x cubed, so that'll be 2 over 3 x cubed. This will be negative 1/2 x squared, and that'll be 4x. Okay, and I'm going to evaluate that from 1 to 4. I'm going to switch the slides here just because I was out of room. Okay, so I plugged in 4, and then I subtract me plugging in 1, and now I just do all the math to that. Okay, you can pause me at any time to do the math yourself, but just like the cooking show, I already have the answer for you. It's a 93 over 2. Okay, 93 over 2. Okay? All right. Now, let's try this guy. Determine the area between y, that's a typo there, that should say bounded by y equals x cubed minus 4x and y equals 5x. Okay, again, I'll just hide myself very quick so you can see the equations: x cubed minus 4x and y equals 5x. Okay. All right, this is one where just my own knowledge of how these guys work, a cubic function is going to go up and down and up, right? And then y equals 5x is just a straight line that passes through the origin. So I want to look for intersection points here. I was not given any boundary points, right? So I'm going to find those intersection points so I know where the graphs will be on top of each other, okay? So the intersection points, I end up with x cubed minus 4x equals 5x, which is x cubed equals, so I'm going to bring my 5x over, sorry, x cubed minus 9x equals 0. Factor the x out, and I've got x plus, I end up with x times x squared minus 9 there, which is the difference of squares, and I factored that to x minus 3 and x plus 3. So I actually have 3 intersection points here, one at -3, one at +3, and one at 0, okay? -3, +3, and 0. Okay, so now if I think about what these two graphs would look like together, I'm gonna get something like this. Okay, so here is that scenario 2 that we talked about, where I have 2 different sections that I have to deal with because there's a different equation on top between the 2 sections. Okay, so I'm just going to hide myself so that you have the visual there. So from -3 to 0, it's the cubic function that's on top. And then from 0 to 3, it's the y equals 5x that's on top. Okay, so I'm going to have to evaluate the integral of this from -3 to 0. It's going to be x cubed minus 4x minus 5x. But then from 0 to 3, it'll be 5x minus x cubed minus 4. Okay, so, and then I'll add those two things together. So the total area, I want to put myself back and I just can't find the button. There I am. Okay, so the total area will be area 1 plus area 2. And then this is exactly what I just said. So from -3 to 0, I'm evaluating the integral of x cubed minus 4x minus 5 because the x cubed was on top. So I went who's on top minus who's on bottom. Okay, and then I'm going to add to that the integral from 0 to 3. But notice that this time it's 5x on top. So it's 5x minus x cubed. Now notice I just went right to plus 4x, but you just have to remember that was minus the cubic function. And so that negative would apply to both of them. Okay, so now I need to do the integration. X cubed, the 3 has to come up to a 4. So that'd be 1/4 x to the 4. This has to be a square, so that'd be -2x squared. Oh, sorry, I can just add these together first. My bad. Let's do that. So that's x cubed minus 9x. Okay. And then I can go, I did the same thing over here. Sorry. Okay, I just got so excited, I got to the next step. So let's just simplify them first. So I've got x cubed minus 9x, and then yonder for 0 to 3, I've got -x cubed plus 9x. Okay, now I want to do the integration. So again, my 3 goes up to a 4. This will be 1/4 x cubed. This will be squared, so that'll be -9 over 2 x squared. The 3 goes up to a 4, so that'll be -1/4 x to the 4. And the 1 goes up to a 2, so that'll be plus 9 over 2 x squared. Okay, so I'm evaluating this guy from -3 to 0. That means I'm going to plug in 0. I'm going to plug in -3. I'm going to subtract them. Then on another journey, I'm going to evaluate the other guy from 0 to 3, which means I'm going to plug in 3. I'm going to plug in 0. And I'm going to subtract them. Okay, my font got small there because that was a long thing. I couldn't fit it all in. But this is exactly what I just said, right? I plugged in 0. I plugged in -3, and I subtract them. Then for the other guy, I plug in 3, I plug in 0, and I subtract them. Just like we did in lesson 4, okay? Okay, so now I'm just starting to clean this up. And as far as numbers go, I end up with 0 minus -81/4 plus 81/4 minus 0, which is 81/4 plus 81/4. total area is 81 over 2. Okay, total area is 81 over 2. All right, so now that's all you got to do today. Okay, piece of cake. So here's your homework. Again, show me your work, show me your steps, communicate like the wonderful communicators I know you are. And if you have any questions, get in contact with me. Okay, take care, guys. Bye-bye.